Hello, in this video I'm going to show you an illustrative example on how to solve facility location selection problems. We will apply the load distance method and we will use the center of gravity method in order to find out the ideal coordinates for our facility. So let's begin with identifying the problem. General speaking, companies usually produce products and deliver services to clients. So we have to identify whether we can find some optimal locations so as to serve customers throughout our retail facilities or customer centers, or the ideal locations where we will build our plants either or our distribution centers in order to deliver products to a variety of our retailers. So we need to decide on physical locations on how to build an optimal network of facilities. So its location decision has its own challenges, and it's not very easy to find out the optimum sometimes. And the same applies either we have services or tangible products. In general, the goal is to identify locations to build our facilities so as to maximize the efficiency of our production and, of course, our revenues, and at the same time, minimize the cost and any side effect that we might face. So let's begin with an example of a frozen pizza manufacturing plant. We imagine that we would like to identify the best location in order to build a plant where we will produce frozen pizzas to deliver to retailers. Our example is more or less the same. We have a pizza plant that we need to decide where to build it, and we examine different combinations of locations. As a first example, we set our plant at some point, at some place, and we know that we have to deliver our products to three main retailers. Those retailers are located in city 1, 2, and 3, and those are the distances from our plant. If we gather all those distances into one table, we can identify that we need to deliver for city 1 10 tons per month, for city 2 retailer 20 tons per month, and for city 3 5 tons per month. The distances are given us, as you can see here. So one approach is to identify one weighted, one number, one metric, which is the weighted delivering, which is the tons, weighted by the distance. So if I multiply the tons by the distance for each row here, I get those numbers. So 10 times 34 gives 340 and so on. So I get a metric here, the total, which is 2,240. This indicates a weighted number, which is not, of course, real, but it indicates, let's say, how long my tons are traveling in this network. We might, let's say, we might not be very happy with that. So we might say that if we try another setting in our location, for example, this one, and try again to calculate this table, this weighted load for the tons, if we apply the same approach as before, here we find that the weighted sum of those products is equal to 1,065. And we see that if we follow this setup, then we achieve half of this weighted load. So as you can, of course, imagine here, we have a reduced delivery time because, as you can see, we have placed our plant somewhere between those three cities, so the distances are substantially smaller than before. So we achieve reduced delivery time, we achieve reduced cost, and of course we increase our efficiency. One question that is quite critical, though, is whether the cost of the land here in this setting allows us to have the reduced cost in total, because we might gain in delivery time, but we might have some extra or substantially extra costs due to land in this place. But whatever it is, we apply here a method, as you see, and this method is the load distance method. It is one of the possible methods that we use in order to solve location problems like that. And the overall approach is to try to find out some factors that influence our decision. The factors could be, some of those could be the proximity that we need to have with our clients or markets, the proximity to suppliers and resources, or some other company facilities. So all those factors affect how fast our load will reach our clients. So we identify in every industry the load as a number. What do we mean by load? We may, in some cases, we may consider the shipment in tons to our suppliers or to our clients, or we might consider the number of customers or employees, the volume, or the miles that they have to travel. In any case, we need to quantify what we actually mean with load. In general, we want to ensure that our loads travel short distances, and we need to find out the best location that minimizes the sum of the loads multiplied by the distance that load travels, which is actually what we did before. So let me repeat that. In the load distance method, we consider that we have a load to deliver to our clients, and we want this load to travel as less as possible. This is the whole idea behind this method. To achieve that, we need to, of course, know the distances. The distance could be either given as a kilometer or mile, or we could have some coordinates. We're all very familiar with coordinate systems, with GIS, Geographical Information Systems, and GPS systems that provide us with coordinates. Coordinates could be either longitude and latitude measured from east to west, from Greenwich meridian, or north to south of the equator. Or it could be some Cartesian coordinates on the map relative to some other position. Whatever it is, we don't have a problem, because what we actually calculate is the Euclidean distance of those coordinates. So applying this formula, we calculate the distance that our coordinates are showing. Whenever we want to apply this method, what we actually identify is the x star and y star coordinates. Those two numbers are the longitude and latitude, the ideal coordinates of our location. So it actually resembles to the center of gravity that we are familiar from science. So in order to find out the ideal location, assuming that we're speaking about a single facility location, finding one only location, then what we're looking for is the x star and y star. And as you can see here, we add the products of load and x coordinate, load and y coordinate, and we divide those by the sum of the loads. Let's just try an example to figure out how all this works together. Assuming that we have a map like that, a grid, where we actually don't care if we have absolute or relative coordinates. In our case, we have city 1 with relative coordinates 2, 8, city number 2 with relative coordinates 4, 2, and the city 3 with relative coordinates 8 and 5. Now, the question that we are looking for to solve is where should we put our pizza plant? So we're looking for the x star and y star coordinates. So if we if we build a table like that with the cities, the x and y coordinates in a separate column, The loads, as before, are 10, 20, and 5. Then we start by multiplying the load times the x and the load times the y coordinate. We calculate those numbers and we find their totals. As soon as we do this, we are ready to apply the formula as before, which is, as you can see here, x star, which is our the x coordinate of our center of gravity. So it is the sum of this total, which is 140, divided by the sum of the loads, which is those three numbers, 10, 20, and 5, which add up to 35. So the x coordinate, the x star coordinate is equal to 4, and the y coordinate is equal to 4.14. So our ideal position, our ideal location on the map would be to place our plant at that position, at that location. However, as we said, we need to examine a lot of additional factors: the cost of land, the cost of employees, maybe if we're operating in another country, how easy it is to build a plant there, politics, influences, and all those external factors that affect our decision. So that's a very elementary problem that shows how to apply the center of gravity method in order to find out the best location for one single facility. I hope you found it interesting. Thank you for watching. Thank you for listening.